bar graph is controlled by a shift register that allows the control of outputs. The clock pin on the shift register lets the shift register know when the bits are going to be shifted in. The data pin takes either the high or low and shifts it into its place. When all the bits are shifted into their outputs, the result will show on the bar graph. The latch pin on the shift register, when low, will not display the bits shifting through. When the pin is pulled high, the bits shifted through will be displayed on the output. The software component of the binary button echo is the variables are initialized before the void setup, and an array is set of all the buttons as they are all inputs. The void setup initializes all the pins that are needed for the binary button PCB, and all the buttons are initialized through a for loop, which runs through and sets them all as inputs. The first part of the void loop is the for loop. This for loop loops 8 times, once for every button. Inside the for loop, the function bit_write is called. This function writes a high or low to a bit in a variable. The variable that is used is the variable that was initialized to display on the bar graph. The first button writes to the first bit of the variable, the second button writes to the second bit, and so on and so forth. Since these values are the same, the I is used as a placeholder, and every single time the for loop is called, I increases by 1, so you go through every single button, writing to every single byte. After the byte has been assembled, the latch pin is set low, and the Arduino shift out function is called, which does the heavy lifting with the data and clock pin. All that is needed to be passed out is which way we want the outputs to appear, and we want the most significant bit, not the least significant bit, and the value that we want to display on the bar graph. Then the latch pin is set to high, and the values will be displayed on the bar graph.